Okay, the time is here, end of the semester, and we have the upgraded Arduino project. So with the original build that I had for the simple project, it was the LED bar graph. Now for the upgraded project though, I wanted to do a ultrasonic sensor, and with the ultrasonic sensor, there is data that is displayed with it. So I wanted to also do the LCD screen. And with that, I was able to find the parts on Tinkercad, but what I was not able to find was the board and a few other things. So I just completely dropped out of the Tinkercad software and I went to fritzing. Okay, so now beginning with fritzing, due to not being able to find the Arduino Mega board on Tinkercad, I have to use fritzing, which does have the Arduino Mega because I need the extra rail to supply input connections for all my component items for the upgrade. But yes, it comes at the cost of having to rebuild my original simple project, but no worries. Just connecting all the LED lights, I did swap out some colors. I want to get a proximity meter at the end of this with a meter type lighting system. And I'll go ahead and get those connected all to the Arduino board and to 220 ohm resistors. One drawback of having to use these simulators is that it is a 2D landscape and you sacrifice a lot of your connections, as you can see here, due to having to lay out the components in a schematic type view. The ultrasonic sensor is very simple. It has 4 connections, and your 2 main ones will be the trigger and echo, which triggers an echo out, and the echo captures that pulse ping that comes in. But there's no visual confirmation or visual way or visual aid to see that happening in action. So I've installed these 2 blue LED lights. I watched a recent video on YouTube and it kind of changed a little way of how I build these components, kind of like cable management, whatnot. As far as the LCD screen, there's a lot of connections on the LCD screen and some are used and some are not used. There was some discrepancy about using a resistor with one of the ground outputs, but I was having issues overall, and then found that you could have used either way. Not sure, but I went ahead and went with the setup that got results for me. I just need to power the rail up and ground it and complete kind of my circuit. I did have some drawbacks on power, so I had to make some accommodations, or maybe it was just the camera quality on the physical build, not sure. And then the final part is the potentiometer. Without getting rid of it completely, I found a use for it with the LCD screen, which was to control the contrast. It was just too big and absurd on fritzing for me to put on the board itself. And then the layout of the LED lights also restricted my space. But no worries, I'll have it attached on the outside and then make my last modifications for clarity on the board itself and maybe change a few colors. But there you have it. That's it. Code compared to the original simple project. Mainly these lines from 3 to 7 and way here at the bottom 108 to 117. So I've got quite a bit of code in between, but we'll just go quick line through line to showcase what each code block is doing. In the initializing stage, before doing anything with the Arduino board, we're going to go in and we're going to declare everything that we need to declare. So as with the simple build, there's 10 LED lights, and with the 10 LED lights, we're going to assign each one to its pin on the Arduino board. Nothing changes from the simple build, the original build. Now we're going to move on to the ultrasonic sensor. And with that, there's the 4 pins, only 2 of which has data or needs to be declared and attached to the Arduino board, which would be the trigger pin, which we've set at 23, and then the echo pin, which we've set at 22. Now, with the LED lights, there's the light pin for the trigger and the light pin for the echo. So to keep them all nearby each other, we set it to 26 and 27. These are constants, will not change. Now, for the calculations later on, with the pulses, pings that are coming out of the sensor, we have our mathematical type variables, ping travel time, ping travel distance, and the target distance. Onto the liquid LCD screen, we will have to include a library in our code for the LCD liquid crystal class. We won't be able to use any of its functionality without including this in our program. Going down to the line item code, we will need to create variables for all of our Arduino connections. And then in order to print out any characters or have any kind of output data onto the screen, we need to declare a column and row variable to be able to position it on the screen itself, whether it be on the top row of 16 bits or the bottom row of 16 bits. The void setup is what we will fill with everything that we need to do before going into the main loop. Similar to kind of like a do while, you could say, it's going to at least do these before going into the loop itself. Or maybe I'm not picturing that correct, but that's how I see it. So to begin with the setup, we will initialize our serial output, and then we will go in and go to create our original loop from the simple project to initialize all the LEDs. Next, we will go to the ultrasonic sensor and set that to output and input so that it registers what its function is going to be. And then we go into the LCD and we set up the 16 bits per row on 2 rows. And to do some startup messages, kind of test out the system, we will go in and we will do a printout at position 00 on the LCD screen. And we will print out computer science CSCI 2350-SP24. And then on the bottom row, we will print my name. And then we will wait for a few seconds, clear it out, display a new message. But this time we are going to set it 1 space over on the column at 10. Wait, and then we'll clear the screen again. And then we're going to do a initializing kind of dynamic screen moving. So for good practice, I just did the LCDs clear in between each one. And then we move on into our void loop, which is the main loop of the program. To begin in the main program body, we will set a permanent reading on the LCD screen of proximity inch. This will print out at the top. We're going to set this at column 0, row 0. And then our ultrasonic sensor will begin to do its thing, beginning with triggering its pulse ping out with a delay of 10 seconds. And then we are going to trigger it off, and we are going to activate the echo to capture the ping pulse on its return trip. And once it intercepts that, it will have our variables to do the calculations that we need to do to determine the distance of the proximity. And while it is doing its function, the light pins, the blue light pins, are going from high to low, and you'll be able to see the ultrasonic sensor in action. Now, for the calculations, after doing some research, the best thing that I found to do was to take the speed of sound, converting it into inches per microsecond, and then calculating that value with the data value that's captured by the ultrasonic sensor. And then by having that value, I was able to determine the distance of the proximity by dividing it by 2, because the pulses and the pings have a outgoing and incoming travel path. So we only need to know either one of those 2. So we just divide that value by 2. And then we get into the end of the code, which was from our simple code. And this time, instead of having the map based off of the potentiometer, this time we will take the travel time of the ping and pulse before dividing it by 2. And we will set it up as a map in relation to the 10 LED lights. And then that will show us the proximity. So as the value of the distance decreases near 0, the LEDs should map up and light up and illuminate all the way, all of them, all 10. But this should capture everything. It might not be the prettiest. It could be consolidated, fine-tuned, whatnot. But this is my first experience working with most of these, so it might kind of look jumbled up. But it's time to test this code on the physical build and see what happens. Thank you for watching my video. As with all the coursework that is given, it's always best to search many different avenues of resources and information. And yeah, that's it. Take care.